Dear students, we are here to continue with our interaction on alignment design as a part of the course Geometric Design. Just to remind you, we are continuing with the module 3. In the previous interaction, we talked about extra widening, which was denoted as WE, and we discussed that what are the reasons due to which this extra widening needs to be provided. It is to be provided on either side of the carriageway or is to be provided on the inner side of the carriageway, and then how we are going to calculate the value of this WE, which is a composition of two components, that is the extra widening which is there because of the mechanical reasons and because of the psychological reasons. Now, with this, now let us move to the another thing, which is transition curves. If you remember, when we were talking about the super elevation design, and then we talked about the attainment of the super elevation in field, then there also we have discussed that attainment has to be done all along the length of the transition curve. And the same thing has been talked when we were discussing about the extra widening, and there also we said that the extra widening has to be provided at a uniform rate all along the length of the transition curve. So, if the transition curve is being provided between the straight and the circular section, then all of those components are going to be placed with respect to this type of a curve. Of course, we also talked about that if the transition curve is not there, there is a straight section which is directly connecting to the circular section, then in those cases how the super elevation or the extra widening needs to be provided. Let us start our discussion on the transition curve. Now, the transition curve, as we have been talking again and again, is nothing but we have a straight section which is also being defined as tangent, and we have a curved section, and this straight section and curved section are going to be connected smoothly by way of a curve. And because this is a transition, because we are going from a straight section to a circular section, hence the name transition curve. So, it connects the tangent with the circular curved section. Now, if you are looking at this, then what happens is that the radius of the transition curve, how it is changing. Now, when you have a tangent, then at this tangent the radius of the transition curve is an infinite value. Whereas, when you are on a circular curve, then in this case the radius is a finite value R c. So, at this point it is R c, whereas at this point it is infinite value, and therefore, there is a change in the radius of this transition curve from infinite at the tangent point to a finite value when you move along the transition curve, and the value obviously when you are coming to the circular curve is nothing but it is the radius of the horizontal curve. So, you have a change from infinite to a finite value, and this type of a change when we are doing, then the rate of change of radius along the length of the transition curve. Now, this is going to be dependent on the selection of the type of the curve which we have as a provision for transition curve. So, this rate of change of radius is to be looked at, because if this is happening all of a sudden, if you are moving on a straight section and all of a sudden a curve comes, then you will feel a jerk, because there is a application of the centrifugal force in that case. So, we need to see that what is the shape of the transition curve, what is the equation and how it is going to be implemented, whether it is easy to do that, whether it is easy to compute the values, and all of those things are there when we try to select a type of a transition curve which satisfies and which tries to provide you this type of a scenario where R from infinite to R is equals to R c is going to happen. So, what are the various functions which the transition curve is going to perform? The very first thing which we say is it provides a smooth transition. It provides a smooth transition from an infinite value to a value R c. So, slowly and slowly this thing is getting introduced, and therefore, you do not feel when you traverse from a straight section to a curved section. It provides a smooth introduction of the centrifugal force, because slowly and slowly you are going to have value of R, but you are still continuous moving with a design speed V, whether you was on a straight section or you are on a curved section, the speed is V. Now, when you are coming on this curved section and there is a introduction of P. So, what we are trying to do is that we are trying to change the value to R c, and because you have m v square divided by R c, and this R c is changing from infinite value to a finite value. So, slowly and slowly this is happening, and therefore, this is a smooth transition, a smooth introduction. So, you do not feel any jerk in this particular case. Then it provides a smooth transition for the implementation of the super elevation as well as the extra widening. So, this is another thing we already talked about. We said that we are going to start with a value, say in the case of super elevation we said that we are going to start with a value of a camber C, and at the outer side it is 0 from this particular situation to a value where we have provided E. So, this is going to be on a tangent, and that is why this length was defined as the super elevation runoff distance. Similarly, is the case that it is happening with respect to extra widening, changing from 0 to W e. It enables the driver to steer the vehicle comfortably, safely and smoothly, and improves the aesthetics of the curve. So, because if you have this type of a curve and all of a sudden a curve is going to be there. So, you have a straight section and a curved section. So, aesthetics are not going to be good, but when you are slowly connecting in this form, then this aesthetics are going to be much better. So, that is another reason why we should try to have a transition curve as far as possible. Now, what can be the types of a transition curve? So, when we are going to talk about the various types of the transition curves, any one or all of those should try to satisfy few of the things, and those are the things being given here. What it says is that the radius of the transition curve shall change gradually from infinite to finite value, so that the centrifugal force does not act instantly and does not cause steering of the wheels difficult, or there is not an application of the sudden jerk which cause the vehicle to go out of control. So, this is very first thing. So, a gradual introduction of the radius from infinite to a finite value. Now, another thing is you are going towards a circular curve on which a centrifugal force is going to be there. So, therefore, the rate of change of centrifugal acceleration is another thing which needs to be looked at, and it should be such that it does not cause any discomfort or jerk. Okay, so, this is one another thing, and for this the radius of curvature at any given speed shall be inversely proportional to the radial acceleration. So, if we say that we are talking about the radius of curvature. So, this is like radial acceleration, or we can say A r is inversely proportional to that, but then this is for a given value of the speed. And in that particular line, the another thing is that the radius of the curvature shall be inversely proportional to the length of the transition curve from the start of the curve. So, what we are saying is that this radius of curvature is inversely proportional to the length of the transition curve, or what we can say is that R c into L t, this is going to be a some constant. So, this becomes one condition otherwise which needs to be taken care of. So, when we talk about all of these cases, all of these requirements, then we have to see that whether the various types of the transition curves which are possible and which have been mentioned here, say a spiral curve or lemniscate curve or a cubic parabola and all these, are they going to satisfy these particular things or not. So, we have different type of curves, say we have a spiral curve, we have a cubic parabola or lemniscate curves. They have their own properties, they have their own equations, but on the basis of overall system, that means we need to see first of all the satisfaction of the requirements, then we need to see that the equation for calculation purposes, and another thing is the setting in field. So, these are the three things which needs to be taken care of when we are considering these across each other, when the comparison is being done between spiral, cubic parabola or lemniscate. So, in these cases usually the spiral curve is being utilized because It satisfies the requirements of an ideal shape of the transition curve. So, we have talked about the criteria just before. Then it has the geometric properties that the calculations are simpler and it can be set in the field in a easy manner, and the product of the length of the curve from the start point and the radius of the curve at the point is constant. So, that is what we discussed, that R c into L t is constant. Here we say that R c at a point P and the L t up to a point P is what we are talking here. So, that is the way we present it. So, we have got the criteria now in hand. We talked about the centrifugal acceleration, we talked about the super elevation and the extra widening, and they have become the criteria so as to calculate the length, because all of these things have been provided along the length of the transition curve. So, the very first criteria which we are looking here is the rate of change of centrifugal acceleration. So, in the case of this rate of change of centrifugal acceleration, the length is being found out as V cube divided by C r, where V is in meter per second. So, this is a design speed, but if we convert it into kilometers per hour and use it as capital V, then it becomes 0.0215 V cube divided by CRC. And what are C and RC? The C is a constant which is related with the rate of change of centrifugal acceleration, and this needs to be calculated. The formula for calculating this is 80 divided by 75 plus V. So, it is dependent on the design speed. So, once you put the value of the design speed in this equation, you will get some value. Now, what you have to see is that it has a certain constraint. The constraint is that at a minimum level the value can be 0.5 and at the maximum level value can be 0.8. That means, if you have calculated C is equals to 80 divided by 75 plus V and this comes out to be 0.428, then we are going to consider C as 0.50, or if this comes out to be 0.852, then we are going to consider C as 0.80, but if you have any value between 0.5 and 0.8, then that can be considered as such. And RC is the radius of the horizontal curve in meters. So, that is the value we are going to put in here. The another criteria is the rate of change of super elevation, and the formula for that is capital N into E into the total width at the circular section, which is W plus WE, multiplied by a factor E. Now, capital N we have discussed before also, which is nothing but is the rate of change of super elevation along the length. So, how we are going to provide the super elevation, that is what we are talking, and it is dependent on the terrain. So, what it says is it is a plain and rolling terrain, or it is a steep or mountainous or a hilly terrain. Depending on that, you are going to get this value, and this value is 150 if it is plain and rolling terrain. At a minimum level it can be 200 and so, and at a minimum level it is 60 for a steep and mountainous terrain. So, as flat as possible is the point that we should try to maintain. E, which is being considered here, we have already discussed, it is a design super elevation rate, and it has the maximum values which we discussed as desirably we try to provide it up to 4%, but we can go to maximum 7% and in certain conditions can also use a value of 10%. And depending on whether the value of the radius is being provided in actual or is as per the design, whatever the values are there, the comparison of that also allows you to use a value of 5%. So, we had these values in hand. So, we can calculate, either we can design it or otherwise we can utilize the maximum values which can be possible, which is going to give you the maximum length for the transition curve for this particular vector. W is the extra widening, W is the width of the carriageway. Now, A is what? A is a factor which is dependent on the way the pavement has been rotated so as to attain the full super elevation. Now, we talked about it that if we have this as a center line and we are going to move our pavement about it. So, we have a say this pavement like this, and if it is being moved, so this is how it has taken up and down. So, the value which is going to be there on this side or the value which is going to be there on the other side, this is half of that super elevation which is to be provided. But if we are looking at a situation where this is inner side and the whole of the movement is being done of the outer side, then this is nothing but E. Similarly, if you have an outer edge and if you go inside with respect to inner edge, then in this case also this value is going to be E. So, considering these things, the A is 1 for the pavement rotated above the inner or outer edge, because the whole value of E is to be provided, or it is 0.5 when it is rotated above the center line. So, that is how we are going to find out the value of the length using this formula. And another case is the empirical case, which is being provided for plain and rolling terrain or urban roads as well as hilly terrain. So, in the case of urban roads and plain and rolling terrain, it is 2.7 V square divided by RC. So, in the case of urban roads, we can simply stick to this formula, calculate the value and provide it. In the case of hilly terrain, it is V square divided by RC, and again V is design speed in kilometers per hour and RC is the radius of the horizontal circular curve in meters. Now, when you are looking at this length of the transition curve, now these empirical formula, they have been derived for a 2-lane roads. Now, what are the locations where it has an applicability is what is being talked next. It says that it can be applied to the single lane as well as it can be applied to a 4-lane divided system, because in the case of 4-lane divided system, you have the median here and then you have a lane, 2 lanes on that side and 2 lanes on this side. So, this becomes a 2-lane and 2-lane. So, a 1 carriageway is a 2-lane carriageway, 2-lane single carriageway, or a 2-lane single carriageway is what we are looking or we are talking here. So, in all of these cases we can utilize this formula, but if you have a 4-lane undivided and a 6-lane divided highway, then in that case the length is increased by 50%. The length of the transition curve shall be provided as the maximum of the length calculated by the 3 formula. So, we have a formula related to the centrifugal acceleration, we have a formula related to the super elevation and an empirical one. So, we use the all of those 3 and then we calculate. In the case of urban roads, we are going to use only one. So, this table gives you the values of the length of the transition curve. What you can see is this is a plain and rolling terrain and this is a mountainous and steep terrain. So, we have the radius of the curve being provided here, changing from 15 to say 1000 meters, and here we have the speed value in kilometers per hour. Now, what you found is that there are few blanks being provided on this side and there are also few blanks which are being provided on the other side. Now, when we are talking about any of the speed, say 30 kilometers per hour, for that 30 kilometers per hour we have a criteria of a minimum value of R, and if we put the values here, what we found is that we are usually not going to provide something below say 30 meters of a radius. So, that is the reason it says it is not applicable on this side. At the same time, when you are talking about the other side, what happens is that after certain particular value of R, there is no need of providing the super elevation. So, the radius is there, a minimum radius beyond which if the radius is being provided, no super elevation is required, we simply use the camber, and for that the equation is V square divided by 225 into C. So, using this particular value we can find out what is this radius beyond which it is not required. So, we have got now the extremities within which we are going to have the length of the transition curve and they have been calculated here and being provided. So, you can utilize the equation and find it out that what is the value. So, if this is for urban roads, in the case of urban roads, then you are going to use for plain and rolling terrain the formula as 2.7 V square by R, or otherwise a single 1.0 V square by R for a hilly terrain. In the case of expressways, the values are being defined for the 3 categories of the speeds, that is 80, 100 and 120 kilometers per hour, and for those we have 70, 85 and 100 meters as the minimum length of the transition curve. Let us have an example here. We have a 2-lane national highway passing through a plain terrain. The design speed is 100 kilometers per hour. So, V is 100 kilometers per hour. The radius of the circular curve is 400 meters. The wheelbase is 5.5 meters. Maximum rate of the super elevation is 7%. And we are looking at here is that the pavement is rotated about the center line of the pavement. So, that situation is there. We have to calculate the length of the transition curve. So, we have 3 sets of equations. One is related with the rate of change of centrifugal acceleration, another one is related with the rate of provision of the super elevation, and the third one is an empirical one, and here it is plane terrain. So, we are considering 2.7 v square divided by R c. So, when we talk about the first one, the constant c has to be calculated, which is 80 divided by 75 plus v, and when we put the value of v as 100 kilometers per hour, what we get is 0.457. But the minimum allowable value for c is 0.5, and therefore, we are going to use c is equals to 0.5. Then it is rotated about the center line, that means a is 0.5. So, that a is also known, c is also known. Now, what is about W e? Now, W e, it says the radius of the circular curve is 400 meters. So, in that case there is no requirement of W e. So, W e is nil for that, and for plane and rolling terrain the minimum value of capital N is 150. So, now we have got all the values in hand. So, we can calculate the lengths. So, what we found is the first criteria gives a length of 107.5 meters. The another criteria, when you put the values, gives a length of 36.75 meters, and the empirical formula gives a length of 67.5 meters. Now, here E value is being considered as 0.07 for a plane terrain. We have not tried to find it out or design this value. What we have done is that because this is the maximum value, so the maximum length which is going to be there is with respect to this, and with that notion we have gone into the calculations. Now, what we get is the maximum is 107.5 meters. So, this 107.5 meters can be provided as a length of the transition curve. Now, that is another case where we have a 4-lane divided highway. So, it is passing through a plane terrain. So, that is another thing. Design speed is 80 kilometers per hour, radius is 300 meters, wheelbase is 6.1 meters, E is 7%. And the pavement is rotated about the outer edge of the pavement. So, it means it is A is equals to 1.0. So, again going with the same 3 formula and calculating the value of C, what we get is 0.5161, which is within the range of greater than 0.5 and less than 0.8. So, hence it is OK. So, we are going to calculate to use this value as 0.5161. So, capital N for the plane terrain at the minimum level we have to take as 150. So, we are taking it, and say we assuming that for this 300 meter condition on this multi-lane system, the extra widening is going to be roughly around nil. So, if we go with this and we are not calculating this value here, then what we get for the 3 cases is 71.10 meters, 147 meters and 57.6 meters. These are the 3 values which we get. And using these 3 values, then the maximum is 147, which is provided as a length of the transition curve, and it satisfies all of the cases, the 3 cases which are going to be there. Now, when it come back to the design elements, we have discussed about it previously, and just referring it back. So, we have a circular curve here, we have a transition curve on this side and a transition curve on the other side. There is a shift S, there is a deflection angle or a deviation angle delta. The length of the transition curve, when we talk about this shift, the shift becomes half of the length of the transition curve. So, this is half of the length of the transition curve. So, you have S by 2 here and S by 2 on this side. We have to calculate the angle phi for the transition curve side. So, it is going to be dependent on the radius up to the point here and the length being considered as L by 2, and once we have phi on both sides, it means for the circular curve what we are left is delta minus 2 phi. So, considering all of those things, the shift is, as we have discussed before, Ls is square divided by 24 Rc. So, where Ls is the length of the transition curve. Phi value, which is the angle related to the transition curve, is Ls divided by 2. So, half, and this divided by Rc plus S by 2 in radians. The tangent is Ls by 2 plus Rc plus S into tan of delta by 2, and the angle for the circular curve is delta minus 2 phi radians. So, these are the values which are going to be there, which we need to consider. Now, let us have an example here for this. We have a 2-lane road. This is a national highway and it is in hilly terrain, and it is also being bound by snow. So, there is a high altitude and the snow is there. The radius of the curve is 60 meters, design speed is 40. So, we have R, we have capital V, we have hilly terrain. So, hilly terrain, when we are going to find out the length of the transition curve, that means n is the value as 60. 2-lane road means it is 7 meters wide carriageway. Then we have the length of the wheelbase as 6 meters, deflection angle delta as 60 degrees, because this is what we are talking as delta is 60 degrees, and the pavement is rotated about the outer edge. So, and it is rotated about the outer edge. So, it is A is 1.0. We have to calculate the length of the transition curve, the length of the circular curve and the total curve, and the tangent length of the combination of the circular and the transition curve. These are the characteristics which we need to calculate. So, we have W7, R60, V40, N60, small l as 6 meters, delta as 60 degrees. Rate of supervolution E is going to be 7% for hilly terrain, snowbound condition, number of lanes N are 2. So, the extra winding which we get is 1.116 based on the total formula is W m plus W p, and if we talk about the constant C, which is 80 divided by 75 plus V, what we get is 0.6956, which is again okay, because it is falling within 0.5 and 0.8. So, once we have got all the things in hand, let us calculate the values by 3 criteria, and what we get as the length in the first criteria is 32.97. In the second criteria, we have got the calculated value as 37.09, and in the third one as 26.67. So, the maximum of the 3 is 37.09, which is being considered. Now, shift S is L T square by 24 RC or L S divided by 24 RC, whatever notation we take for the length of the transition curve. For that, what we get is this shift is 0.955 meters. Angle of the transition curve phi is L T divided by 2 into R C plus S by 2. So, what we get is 17.57 degrees. So, the angle for the circular curve comes out to be delta minus 2 phi. So, phi is already being calculated as 17.57 degrees. So, what we get is 24.86 degrees. So, length of the circular curve comes out to be 26.04 meters. The tangent length, which is summation of the two, that is half of the length of the transition curve plus after that the tangent value. So, this comes out to be 31.98 meters, and the length of total curve will become the length of the transition curve on either side plus the circular curve. So, it becomes 100.22 meters. So, this is how we can calculate the various characteristics of a combination of the curve also. Now, let us talk about one another case, that you have a combination of curves. So, compound curve situation is there. So, we have discussed about this compound curve situation, that there are two curves like this. Now, length of the transition curve between the compound curves is to be provided. So, here these have to be connected. So, you have circular curve here, you have circular curve here, and you have transition curve in the center of these two. So, that the things becomes perfect. So, when you are looking at this, then the length of the transition curve between the compound curves is nothing but it is the difference between the lengths required for changing from tangent to circular curve for each type of a curve. So, we have a length required for TC from curve 1 and curve 2 are there. So, we have L1 and L2, and the difference of these two is going to give us what is the length which needs to be provided. So, LT1 is when we are talking about the rate of change of centrifugal acceleration. So, it is 0.0215 V cube divided by CR. So, R is changing, V is not changing, C is a constant. So, what we get LT as LT2 minus LT1, and when we put the values, so we get as 0.0215 into V cube by C multiplied by the inverse of RC2 and the inverse of RC1, the difference of those two, and this is how we will get the value of this length. So, these are the things we have already talked about and we have already defined. So, RC1 it is for flatter curve and RC2 say for sharper curve, and those are the two curves which have been combined here together. So, this is the way that in the case of a compound curve we are going to find out the length for the transition curve. Now, another thing which is there related to this, where you have calculated the value on the basis of LT1 minus LT2, but there are few points which needs to be taken into consideration, and they are: for the smooth transition, the minimum length of the transition curve should be at least 150 times the difference between the full super elevation of the two curves. So, whatever is the total value of E1 and E2 is going to be there, The difference between the full super elevation for the two curves, if we take, that is E1 minus E2 and 150 times of that, is that what we are talking about as a one minimum length. And in any case, at least 30 meters shall be used as a transition curve between the two curves. The difference in the radius between the two curves shall not be more than 1.5 times the radius of the sharper curve. So, if we talk about R flatter and R sharper, that is what we are saying. This is how. Okay. If it is more, then it is going to result in the sudden change in the curvature, and obviously it is going to be felt by the drivers when they drive their vehicle on this particular section. So, with this we close our interaction today, and we are going to continue with our other things related to the alignment in the next interaction onwards. Till then, thank you and goodbye.